Hello, I'm Tom Hollingsworth, and welcome to Networking Field Day. We're here in sunny Santa Clara, California with NEC at Networking Field Day 13. We're also joined by a group of Networking Field Day delegates around the table who represent the best and brightest minds in the networking industry as bloggers, podcasters, writers, and speakers. They have been invited to this event to take part in discussions, to ask questions, and offer their opinions on technology. If you'd like to learn more about this event series, including how to become a presenter or a delegate yourself, please go to our website at techfieldday.com. If you'd like to see more videos about technical subjects like this, please visit our YouTube channel at youtube.com/techfieldday.
All right, hello everyone. I'm Aravind Sukumar and I'm a systems engineer at NEC Corporation of America. And it's a great time for me to explain about the demo scenarios that we have created to demonstrate the UC integration with NEC's SDN controller. All right, to get started, I would like to start from the scratch. So from the scratch meaning, so this application, the client-to-client UC application is going to be, it's deployed on an SDN network. So the first part of the demo, I'm going to introduce no QoS, no policies on the network, which is going to affect the call quality. You will see whenever there is a burst traffic in the network. And then while the call quality has gone down, I'm going to apply statically programmed QoS on the controller and see how the call quality improves. So how the call quality improves. So this is to get you started into the demonstration, and later I will introduce the application that we have developed that is tightly integrated to work with UC server. So where it can receive the messages from the server about the call quality, user experience, in-call call experience, all these other good terms, and then it can talk to our controller through the RESTful API and then make a decision to apply the QoS policy on demand or something better than that. All right, so let's get into the first part.
Real quick.
Yes.
I'm not sure if it was said already, but is this for any unified communication platform, or is there certain ones that you partner with?
So it is for any unified communications, where we will have to test the integration with our application. And then the current one that I'm going to demonstrate is with Skype Business. And we have one integrated with our NEC's 3C platform. So we are open for other UC servers too.
Okay, do you have hooks into those applications, or is it just, you're just looking at the data that's accepted from it?
So it's typically, we look at the data. I mean, so the UC server is going to analyze the call quality typically. So whenever a call is initiated, UC server, I mean, that's the operation. So UC server receives a call request, and when it receives a call request, it is going to talk to the application and define what type of a call it is. And it just says what type of a call it is. It is an audio or video call. And then the application has a set of parameters based on which it receives the information from the UC server and then translates it into the SDN network.
Okay.
So we are going to have a few windows here. I will give you a brief introduction about how to see this whole demo. So these are the two clients, laptops that are connected to the SDN network. So client, for the demo purpose, the concept of the demo is to show a video streaming, or video call between the clients. But we don't have anybody to, we don't have a model here, so we are going to use a video to stream between the client A and client B. And we'll show, once the call is initiated, you will see the same video that's being shared on the other client screen. And if there is problems, you will see the latency or pretty bad video response. All right, so before getting into the demo, I would like to give you an introduction about the controller the SDN controller that we have, and also this is the topology that we have for the UC SDN network. So there are 4 switches in the network. There are 3 Dell switches and 1 NEC switch, and there is also a PF1000, which is the open flow extension for Hyper-V virtual switch. We saw that last year, and we gave a 2-hour demo on that. And then you will see that the UC server and the applications that is required to run the UC servers are connected to on the Hyper-V server. So you have the Link SDN, which is the application that we have developed, and then the Link front end server, which is the server that is going to allow or create the calls for the clients. And you have the SDN manager and ADDNS, which are required to run. And then we have the Link client 2 over here and the Link client 1 over there on top. And the communication is just going to go past the network. And also I'm going to use the traffic generators to pump in traffic to choke the network bandwidth, so that you will see the call, the quality getting bad when we are going to react in a way, applying policies to improve the call quality. All right, and the next part is we have to introduce about the concept of VTN, which is called Virtual Tenant Network. It is the layer of abstraction above the physical layer. It is a network virtualization construct that NEC has developed. So the VTN is a single network, a single virtual network that is going to distribute the traffic flow across the entire physical switches. So you do not have to configure the devices for VLANs or routing or all those simple things. Instead, you can create the VTN and drag and drop the layer 2 construct or layer 3 construct, which are vBridges and vRouters respectively, and then you can have a pretty simple L2 and L3 network. And if you want to create the policies, like you can add ACL rules like drop or pass or traffic or redirect to a firewall or other services. And also you can apply the QoS policies and such things, and also you can meter the bandwidth utilization, all these things from the VTN view and not from the switches. So that is one of the great features for VTNs, where you can have a central or single point of console to extract the complete detail and also provide the complete functionality to the network. Is that clear? All right. Any questions so far? All right, let's go to the basic part of this demo. So I'm going to initiate a call from Malvin to Garth, and you will see the video is being streamed. Okay, the call is accepted. At this point, there is nothing in the, there are no other traffic in the network other than this video call. So there are no problems. You will see the shark getting in and getting out without any latency or distortion. So all these are good. Now I'm going to ask Arif. Arif is our systems architect, and he is helping me with the demo, driving the demo forward. So I'm going to request him to pump in the burst traffic from the traffic generator, which is going to choke the network, and you will see the call quality degrades. Move it. Yeah. All right, you can see that the call quality has gone down. So this is the first part of the demo. So it is on SDN network. It doesn't mean SDN can immediately do something fancy. So we still have the call quality problems. But how do we counter that? We have, as I said earlier, there are 4 switches in the network. I'm going to apply the QoS policy from the controller with predefined values. The values are going to be based on layer 4 port numbers. So which means based on the port headers, layer 4, the QoS policy will be applied to corresponding traffic. For example, video or audio, all these are going to have specified or predefined values. And this is not limited to port numbers. You can also use a subnet. So you can have a range of subnet to have a QoS with priority A and a subnet of Y, with priority B. So this is also possible, but here we are demonstrating with the port numbers. All right, so he's running the script. This is our controller's CLI, so which is also which is very similar to the switch or routers that you have operational today. So you can, okay, he has committed, and after he added that policy into the network, you can see the video traffic is now better, or it was as before. So this means the QoS is applied on the network, not on the switches. That is the concept of VTN, the abstracted model that I was trying to say. All right, so what we did here was the link application sharing is on range of ports, and the link audio is on range of ports, and link video is also on a range of ports. So any traffic that is coming with this layer 4 will be applied to that corresponding VTN, and also the policies will be applied automatically. All right, so there are good parts of this. We are able to apply the QoS centrally, single point, everything good. But what is the problem here? It is more static in nature, because we need to know the range of ports or which subnet we are going to use for this traffic before we even create something. But I believe the current trend is not about using more static. We want to move more dynamic. So where we need to have some application which learns about the traffic statistics and then immediately makes a call on demand immediately on the network, so that everything gets better. So for that, we are going to install the application. So I want to start from showing you how easy it is to install this link SDN, the UC SDN application. It is on the Windows server. So yeah, just install this. So while installing, you will have to provide the controller's REST API information, like the web address with port 8080, which is a REST API's open port. And then we give the username and password, so that which has access from the application to the controller to make changes on the network. And on top, just to add here, in case you miss out on, there can be questions, there can be multiple controllers, and you may want to choose some particular controller. And if there is some changes that needs to be done, you can edit the config where it will show you an error message that the connection failed or something, and then you can change to the right controller, whichever you want. All right, the application is installed. How to check if the application is installed? So there is a command on the PowerShell. Yeah, so you can go to the services, but also going to the PowerShell, you can do a get message to see the status. All right, these are the status. These are the application. This is the application which has various features available. So the features are distributed like global QoS. I will get into the demo of one by one. And then you can have a dynamic QoS, and then we have port-based QoS and dynamic path policy. So the global QoS is whenever you apply this QoS, any audio, video, or application sharing call that is being initiated after this QoS is applied on the application, the priorities will be set on the network. So it is done automatically, because if you can show me the topology. All right, the topology. So whenever a call is initiated between client 1 and client 2, it sends a request to the the Skype, the front end server. So the server immediately sends a REST API call to the UC SDN control application. The application will then talk to the controller and make necessary changes on the network immediately. So while the call is being initiated, this happens in the backend. All right. So we are going to enable the global QoS policy right now. So everything is in false, true or false. True meaning it is being applied. So we are going to apply the first part, which is the global QoS. All right, we are going to set up the parameters for audio. We are going to set up a DHCP, video, and also application sharing. So all these are going to be on order of priorities, however you want to configure them. Now we are enabling the global QoS. Now if you can show the status, yeah. So now the status, it has turned to true, the global QoS, and the policy settings are also true, which means we have set up the QoS policy that we need. It's all user defined. You can pick any numbers on the DHCP. All right, now let's create a call. And after creating call, I'm going to burst the traffic again. And this is to demonstrate even if there is a burst of traffic in the network, the call quality does not go down. All right. I will show you what is configured on the controller as well once we see this. Okay, it's going good. So you can burst. The traffic okay. So there is a burst in the traffic. So you can see the bit rate is at approximately 700 Mbps megabits, and it's going to the same link. So go to the physical topology. Let's also show the traffic flow on the physical network. Yeah. So this view allows you to visualize the live traffic statistics, the traffic flow between the hosts, clients, or servers, and also the legacy routers or switches that you have in the network, with granular information such as MAC address, IP address, layer 4 if it is forwarding on layer 4, and also which switch it comes in, which switch it goes out. All this information can be visualized right from here. All right, so this is where the link client, the two clients are connecting. And the traffic, the data traffic should also be going through the same path. But the traffic doesn't get congested because we have applied the policies. And if you go back to the CLI, all right, so the CLI, the controller configuration shows, show run, yeah. All right, this name that is picked up by the application automatically when the call is initiated. These are the messages that the UC server tells the application just delivers it to the controller. So these are the list, the conditions created. The condition is based on destination IP and the protocol and the destination port. So the port number is not static. It can pick any port number as needed. So based on these information, the QoS policy will be applied on the network automatically. And this is where the VTN settings are done. So we are applying this condition, the condition that we saw, the IP address and also the port number. And we are setting the priority and the DHCP value over here. So that's where the QoS is applied on the network. Any questions about the global QoS?
It's just that global QoS is usually one thing that you configure once and you leave it.
Yes.
So I think trying to understand is what is the real benefit here instead of just configuring your QoS from the get-go. I understand with the dynamic QoS you can do like a particular call priority, but how regularly do you see that with customers that want that level of granularity with each individual call?
That is inside a campus network. The point is you will have a lot of data traffic as well as multiple other traffic. So the call quality in any campus or enterprise network, there is a high chance of having this degradation. So if you are going to pre-configure, like I showed you earlier, the port-based policy, if you know the values of what policies are or what type of calls you are going to make, then you can go with the static configuration. But the dynamic is for not to lower the job of the network admin. So to make him easier, to make his job easier, he doesn't have to manage all the policies or maintain the, instead the application is going to take care of that. So it's all about moving up one layer. Instead of managing the network, we are managing from a controller. The controller is also managed by an application. So that's the order. Is that clear?
Yeah, so would the entire network, the campus network, need to be running programmable flow?
Today, yes.
Okay.
So right now we need the programmable flow. The controller, the programmable flow controller is needed. But the good part is you can use the Dell switches. We are demonstrating with the Dell switches.
Got
So, and also we work with other open flow switches. So the switches are vendor, I mean the customer can pick any open flow switch
Okay, makes sense.
and just add the controller on top. All right, the next part of this demo, I'm going to introduce something that is going, that's like what happens if there are more traffic on the QoS priority values. So let's say there are hundreds of video calls that are going which are using the same path on the network, because the controller always chooses the shortest path for defining the traffic in the topology or in the network. So what happens if there is a lot of too many people doing a video call or video sharing and something like that? In that case, we have a way to counter that measure by introducing the dynamic path policy. So where the controller can define multiple paths for each type of traffic. For audio, it can take path 1. For video, it can take path 2, and application can be taken on path 3. That is the one that we are showing, but you can also get even more granular, like video, some part of video traffic with subnets take path 1 and some on path 2. So the granularity is available. So in our case, we are going to show, like I'm going to burst the traffic on the priority level, which is going to still congest even though the global QoS is applied, because that queue is congested, too much traffic on that. So, and then the whole scenario is going to be the UC server is going to check the quality, the in-call quality between the clients. And then when the quality is going bad, it is going to talk to the application and say, hey, there is some call issue, or we have a call quality going down. So then the application can tell the controller, change the path or use multiple paths, all available things. So in our demo, we have 3 paths. We'll show in the picture. And you saw that the global QoS, the client-to-client communication was going on the diagonal path, which is both audio and video right now. So now we are going to burst the traffic and first show that the call quality goes down with QoS applied, and then we'll apply the dynamic path where it recovers. Right, let's make a call.
So we need to change the priorities.
Yeah, go ahead.
A good example of a use case that we ran into last time Network Field Day was here was the high definition stream that we were bursting back. We weren't able to accept because there was incompetitive traffic congesting the network. If we had the ability to redirect that traffic on an alternative path, then we could have been able to deliver that HD quality. Instead, we had to manually step down to an SD stream last time.
And with video, it makes sense because it's a lot of bandwidth. Just usually with video, we see the problems on the WAN, not so much internally on a campus.
Oh, good. Okay.
So I was just trying to get the use case for the campus video.
So as a VoIP vendor, we see lots of customers at really not very large scale starting to run into congestion issues once they deploy the converged network.
Good. Oh, wait. So he is increasing the priority for this traffic from 0 to 4, and that's adjusting the DHCP settings. All right. So now, yeah, okay. Make the call. Yeah, initiate the call between the clients. Oh, okay. So before we enable this dynamic path, we have to enable that dynamic path over here, which is currently in false. So let's make it true. Just enable that function and apply that. So these are the 3 paths that we are going to define on the application. Great. All right, so this policy is applied. Let's initiate this call then. Great. So the global QoS is applied, things are good. Now burst the traffic on the higher priority queue. So you can see that it has gone down, but we don't do anything. The UC server sends the in-call experience of the users, and then the application will immediately make the change on the network. So it takes 10 to 12 seconds. Now you can see the dynamic path is being applied and the call quality has improved. Now let's go back to the topology. Now let's see how the flow, okay, this was the existing one. Now we will show what's the new traffic path that is being taken on the network. So you can see the traffic path has changed. So this is for video, and this is continuing to be for audio. And if there are applications or desktop sharing between the clients, then it will go through the third path. So this is how we can counter or get over even if there are more traffic on the higher priority queues. All right, and the last part of this is the dynamic QoS policy. So these are all automatic and also dynamic, I agree, but this is even more dynamic in nature. The next demo scenario. So what the basic of that is, no QoS will be applied for the client-to-client communication unless the client complains about the user experience or if there is some problem in the connection between for video or audio, anything. So the client call will go on, and if there is some problem, it complains, or the UC server will collect the user experience. If the user experience is bad, then it talks to the application. Application will trigger a QoS policy to be configured for that particular client's communication. So that is a dynamic QoS policy. This way, you are not going to predefine or even make so much changes on the network to apply QoS for whatever is unnecessary. And this makes it much more easier to manage the network. So if you look, the entire part of this demo, all these are, I'm repeating, it is applied on the network VTN layer and nothing is configured on the switches. So that is a great benefit of using this SDN. All right, let's initiate the call. So I believe no QoS. Yeah, let's enable that policy. So we are going to enable this policy, which is currently false. Great. So the the dynamic QoS is enabled. Now let's go back to excellent. So the congestion is happening. Okay, so the congestion was happening earlier, so the call quality has gone down. All right. Yeah, you can stop the congestion. Yeah. So let's redo stop this congestion. Yeah. Okay, so immediately it is, yeah, the congestion is created. You can see the bit rate. So the call quality is bad. Now it takes about several seconds, and then the policy will be applied on the network for that particular client-to-client traffic. So it is being applied now. So now they are going good. So that's about it from the dynamic QoS. So we covered from the scratch like SDN network without QoS, how the quality goes down if there are bursts in traffic, and how we can apply the policy based on port or also subnet from the controller. And then we introduced the UC SDN application. We also saw how easy it was to install that application and get it into use right away. And we saw the global QoS policy, and then the global QoS with dynamic path policy, and then finally we also saw the dynamic QoS, which gives us a better user experience for the UC applications. Any questions?
I saw a lot of command line interface, which I love. It's great. But how do you see and manage all of this visually? I see the topology diagram. Can you do all this configuration and management, templating, and all that through that interface?
Through the web UI? You
Yeah.
mean? Yes.
Okay.
So you can, can you open the physical, the web UI? Yeah. So this is a physical map which is automatically discovered by the controller when the OpenFlow switches are connected. And whenever you create a link between two OpenFlow switches, the green link appears. So there are nothing the user is supposed to do over here other than dragging and making it clean look. All right, so the next part is you can also see what ports of the particular switches are available for OpenFlow ports to be used as OpenFlow ports. And if there is another OpenFlow switch connected, it will display which port is connecting to which OpenFlow switch, and you can see the topology details from a single UI. Now coming to your point, click on the VTN. So the VTN can be created, managed, and also deleted. All these things can be done from this UI. Go to the map. So now if you want to, so this is the VTN view. So this is a vBridge, which is a layer 2 construct. So we have a layer 2 traffic across the entire network. So you can see how many clients or hosts being connected on the network. And now if you want to make some changes, so click on, go to config mode, and then click on the edit. If let's say I want to add, this is on, let's say vBridge, VLAN 101. If I have another VLAN that I need to use for the same network, then I can drag and drop a vBridge, and then click on the vBridge and create VLAN 102, and then apply that to the entire network. It can be 2 switch network or 200 switch network. The vBridge, the VLAN 102 will be applied. So wherever the traffic or the host connecting to the switch with VLAN 102, they will be connecting to this particular VTN. So that is a VTN isolation model. And you can have up to 1,000 VTNs, 1,000 virtual networks in the controller, and that way you can have multiple departments or multiple different customers, different departments. They can be virtually isolated, so they will not be able to communicate between each other, even though they use the same subnet, same IPs and other things. And also the QoS policy can also be, or any policies for that matter, ACLs or QoS, can be specifically given to that particular VTN, which means only that customer gets the benefit of that policy. Any other customer, they will not get that benefit. So that is the level of abstraction the VTN provides entire over the physical network. Is that clear?
So what I'm hearing there sounds like VRFs where you can have duplicate addresses.
Yes.
But my question would be, how is that providing segmentation that I can't achieve with VLANs and just DHCPing people into a different address block, say? Why would I need to or want to have the duplicate addresses?
Oh, that was just a point to add as a benefit. You can choose, but I know, it's a good practice not to use same IPs for different hosts to make it more better. But this is an advantage even if there happens to be a duplicate IP. That particular host will not be affecting your network, which could be in the same subnet. So the broadcast will not reach you. That's the.
Or maybe this is something you do in a migration where you're going to work on re-DHCPing
Yes.
people, but
Yes.
fair enough.
Migration story would work well. Yes.
We also have a lot of customers that use that kind of use case for a shared facility, like train stations, like airports, where the individual tenants have their own infrastructure, have their own policies, but it's on that shared resource.
Yeah, well, what I'm thinking is if you have people that are commingled in the same VLAN and you're going to slam them into a new VLAN but keep the same address as part of a migration, that's where